see, your learning target is you can find missing side lengths of similar figures, and you are also going to apply properties of scale drawings. So you're doing two things today, similar figures and scale drawings, all related to proportions. If you know how to set up a proportion, then you know how to do similar figures and you know how to do scale drawings. That's it. First thing you need to know, vocab word congruent means same. And what do I mean by similar figures? They are the same shape, just different size. Okay, similar figures, same shape, different size. For example, this little baby triangle is congruent to this big triangle. Okay. This rectangle is congruent to this rectangle. Congruency, meaning the same, angle measure, and they're proportional. So the angles are congruent to each other too in similar figures. Corresponding sides, they're the sides of the triangle that are similar to each other. And that's huge. This is what you need to know. So let's draw two triangles, similar triangles, with different sizes. A big one and a little one. And then make one line. So we're going to relate the three different side lengths. So we're going to do 1 dash, 2 dashes, and 3 dash. This side corresponds to that side. So big is to small. That's what it's like. The bottom corresponds to what? The bottom. The other side, 1, 2, 3, corresponds to the other one. Okay? That's not very technical. The other one corresponds to the other one, but you can visualize what I mean now. Corresponding sides. That's how you set up a proportion. Side 1 is to side 1 as side 2 is to side 2. Okay, that's how you set it up. Okay, let's see. Another thing about corresponding or similar shapes is they are proportional. And we learned this in the quiz in 6.1 or 2, 6.2, to see if things are proportional when their cross product is equal. So, if I want to say, hey, is this triangle proportional or similar to the bigger triangle? If you don't know, then you can easily find out by setting up a proportion. So I could say, well, 8 is to 12 as 10, it doesn't matter how you arrange it, as 10 is to 15. And then how can you tell if they're a proportion? Michael? Their cross product should be the same. So 8 times 15 should equal 12 times 10. That's 8 times 15. 120. Is it 120? It's 120. So they are similar. You don't have to do that much today, but that's how you really set it up. Proportional or similar triangles and shapes in general are proportional to each other. Proportional means that the ratios are equivalent. So you can do big is to small as big is to small, small is to big as small is to big, or you could do side 1 is to side 2 as side 1 is to side 2. There's 3 different ways you could set up a proportion. Lots of you are going to choose your favorite method. And that's where your knowledge on proportions come in. You're going to find a missing side length today, the application of similar figures. You set up a proportion and you solve. Set up a proportion and solve. Again, this is your learning target, your main learning target, and this is more applicable for MCA style questions. They'll have you find missing side lengths of similar figures. Again, I wrote side is to side as side is to side. However you choose to arrange your sides is your choice. There's lots of different ways to set it up. Some kids like different comparisons. I don't know. I'm going to show you how I do it. I always start 13 is to what? 10. Okay, so Chase said 13 is to 10. So he said side 1 is to side 2 as, now I have to go to side 1 again, as x is to 6. I wouldn't have personally set it up like that. My strategy is 13 is to x as 10 is to 6. But if you know cross products, it's an equivalent equation. It's still 10x equals whatever 13 times 6 is. It's all equivalent. Some kids could set it up like 10 is to 13 as 6 is to x. X is to 13 as 6 is to 10. There's so many ways to set it up. You choose the best method for you. Okay? Okay. Well, now we should actually find it, huh? 10x equals 13, 78. X is 7.8. Okay. All right. Next one. You try to set it up the way that works best for you. I'm going to choose to set it up big is to small as big is to small. You don't have to set it up that way. So I'm going to do big is to small. You could do side 1 is to side 2 as side 1 is to side 2, however you choose. So 22 is to 4 as x is to 7. Okay, so 4x equals 154. X is 38.5. Okay, a more difficult concept aligned with similar figures is inner triangles or inner shapes. The thing is, you need to be able to visualize the two triangles. It will look something like this. So you have a big triangle, and you have a little triangle. Can you visualize the two triangles? Can you see them? Can you imagine pulling them out, separating them? So what you're going to do is create a proportion with the two triangles, and then solve. And again, I've created that little generic skeleton for you. Side is to side, as side is to side. Whatever side you choose to use to create it. Okay, so I'm going to choose to do big is to small. Big is to small as big is to small. That's what I'm going to choose to do. So the big side length, 12, is to the small corresponding side length, which is x. 12 is to x as the big bottom segment. What is the big bottom segment?
14.
What do you think is the most common mistake 7th graders do?
10.
The most common mistake is 10. And 10 is only right here. That's not the whole shape. It goes the 10 plus the 4 for a total of 14.
There's the 4.
As the big bottom is to the little bottom. And then you solve. 14x equals 48. X equals something. My calculator's way over here. 48 divided by 14 is 3.8. 3.4. Okay? So, the main point of confusion is students always forget that they need to add those bottom dimensions, and that's what you need to do. You need to add the bottom dimensions. Not doing this today, skip this. This is for our next lesson. Move on to scale drawings.